All right, Brent Porcio, 3x pitch biometrics of Paul here. We're going to pair him up with Luke Weaver. So we're looking at 240 frames per second, both 144 frames to front foot strike, and the speed and everything measured here is going to be in inches. Speed is inches per frame, and distance from origin is the origin is going to be the back foot on the rubber. So it's going to be, every joint is being measured from that position. The X position is going to be just the horizontal measurement from that origin. And the Y position is just going to be the vertical. So we're going to be going 8 frames per click, so we can see, go through it a little bit quicker. We're then going to start off at 48 frames, so we can see the initial move. And at this point, we can see, if we're looking at the right hips, we can see Luke's right hip is 12 inches from the rubber to Paul's 6. Paul's 6. So Paul is taking longer to start his momentum. You typically going to find high velocity pitchers do a better job of starting momentum earlier. And also too, didn't say these both you guys are pretty much close to the same size. So we can see Luke is moving ahead with a little bit more momentum, or probably a good amount of momentum at this point. Let's go another 6 frames. Let's go to 90, or another 6 clicks. Let's go to 96 frames. And from here we can see Luke's now at 18 inches from the right hip to Paul's 15. So Paul's starting to catch up. So started momentum a little late. Now he's starting to catch up, but you can see still Luke is farther ahead at this point. As far as the force vectors, the ankle to knee, you can see they're almost similar. I would say Paul might be losing torsion. We're always looking for the knee to stay outside of the hip slightly, just so we don't lose stability. If we push too far inside hip, we lose stability. Also, it could be an indication we're driving too early. We want to peak forces late. So we'll follow the drive leg knee coming out of this position to see where are those forces being peaked off the rubber going into front foot strike. It'll be 1 frame per click, and we can see we're at 0.4 inches per frame, and then it looks like it peaked at a 0.4. Okay. At 120 frames. If we watch Luke here, he's at 0.3, 0.4, 0.6. So we saw a big peak right there at about 0.65. Was it a 5? Yeah, 5. Okay. And at 123 frames. So about 3 frames later, definitely considerably faster than Paul at this point. Also, too, we can see Luke's, say, right hip Y position, so the vertical position, 25 inches from the ground, to Paul's 29 inches from the ground. So we can see definitely lowering his center of gravity better, which another key movement common of high velocity pitchers, they take more momentum forward and down to front foot strike. You'd see Paul's pushing him a little vertical or not getting as much adduction out of that hip. So it could be a hip mobility issue, which I feel could be some tight hip abduction here, hip external rotation. Okay, but just a little, you can see Luke peaking later, peaking faster, peaking lower, which typically is going to convert more energy up the body. Okay, so let's watch the hips. When does this peak his hips? Okay, so hits front foot, and literally right after front foot. Very common high velocity pitchers, they'll peak their hips just at front foot strike. Let's see when Paul peaks his hips. So we can see we're well after front foot and the hip speeds are still peaking. There we are. They peaked at, well, actually I'd say no. Looks like they peaked at front foot. So that was good. Once again, Luke peaking them faster. And load the lower center of gravity. We can see 23 inches to the right hip from the ground at 26. Okay. So also stride length. We can see Paul's at 66 inches to we can see Luke's 75. So because he was able to lower center of mass and peak later, built about 9 inches more of a stride length. Let's look at front views. Front views are going to give us an idea of shoulder orientation to hip orientation, front foot positioning, trunk position. The only difference in the front views is the origin is down the middle of the drive foot. So right here for Paul, right here for Luke. So if we take them to front foot strike, we take Luke to front foot strike, we take Paul to front foot strike, we can see Paul is landing. Now in the X position, anything negative is to the left of the origin, anything positive is to the right of the origin. If we look at the left toe, it's landing 7, almost 8 inches to the right of the origin, so he's flying open in his front foot position. Luke is landing 15 inches negative to the closed. So Luke is in a closed front foot position. I would say too closed. 7 to 8 inches is good enough. But Paul is landing 8 inches to the open position, so he's flying open. Okay. And if we look at the shoulder orientation, Luke's left shoulder is a -7 to right shoulder is a -1, so a closed shoulder orientation with a closed front foot position. If you look at Paul's shoulder orientation, he's at a +6 in the left shoulder to a +4, so a slightly open shoulder orientation as well. So definitely have issues with flying open into front foot strike. This could also go back to, it's probably just linear energy is what it's linked to, meaning as he's moving down, there's not enough linear power. The hips aren't continuing to drive forward and down, so things just continue to move open because of the lack of power coming off the rubber towards the target. So we can get an indication of maybe hip to shoulder separation here. We can see Paul's hip is -5, so the right hip is 5 inches to the left, and then the shoulder is 4 to the right. So you could say 9 degrees or 9 inches of hip to shoulder separation left to right. If we look at Luke's, we can see the hips are -10 to the shoulders and -1, so 9 as well. So similar hip to shoulder separation, just more closed orientations, more closed shoulder orientation with Luke. The right elbow then goes another 7 inches behind the shoulder, and Paul's elbow actually is pushing in front of the shoulder at this position. So Luke, it's the same hip shoulder separation, but Luke actually has a more delayed and more horizontally abducted arm position. Also too, if we look at the trunk position, contralateral leaning towards first base, you can see about 7 degrees here with Luke. If we measure this with Paul, we see looks pretty much vertical. It's pretty much straight up and down. And if we go at the point of maximum externation, we see, I have to zoom in on that. Let's see, 25, which is typically anything past 25 becomes excessive, so wouldn't go any farther to 21. We do see though Paul at this point, his head is pulling off, so it's showing that there is not enough linear energy. There's a lot of overcompensation in rotational energy, trying to pull off, flying open too much, and then trying to pull off with the head into shoulder rotation. From here, we're going to watch side views again. We're going to see how well this front leg is stabilizing the stride energy. We have Paul's front knee is 55 inches from the rubber. As he moves forward at front foot strike, it comes back pretty aggressively, which is really good. About 9 inches. So that was really good front leg. But guys that are being rotational can have very good front legs. So, but that's still very good front leg. If we watch Luke, he's at 62. He drifts 1 inch, 2 inches, comes back 2 inches. So not nearly as good as a front leg, but more energy hitting front foot with Luke. So he's having to stabilize more energy. So let's see, this really is a determining factor of how well that energy was converted into the trunk. This has a high correlation to ball velocity and arm stress. So let's see, trunk is 43 inches from the rubber to Luke's 44. Okay. So if we watch from here with Paul, let me see how far this trunk goes forward and how fast it goes forward. So it's 43 inches from the rubber, and it's at 0.5 inches per frame. It jumps to 6, but then jumps down really quick, which right there shows you this is rotational. You just don't see linear trunk slow down that much. So mostly rotation coming out of the trunk. As you can see, the elbow pushing way in front of the face. And at pitch release, he's at 47 inches when he started at 43. So he went 4 inches forward, which is actually one of the shortest trunk passes I've ever seen. So it's just a pure indication that he's extremely rotational at front foot strike. So we'll watch Luke. He's 44 inches from the rubber. And like I said, this is one of the highest correlations of ball velocity that I've found in all these analyses. And we've got 4 inches at front foot strike to pitch release in the trunk speeds. Watch Luke here, 44 inches. As he goes, he hit a 0.9 inch per frame. He's still at 0.56. So he's still at 0.6 inches per frame. So much faster that trunk is moving forward. And he went 66 inches, so he went 20 inches from front foot strike to pitch release. He went 16 inches farther and a lot faster, maintaining speeds a lot longer. That's going to be why his pitch is at 93, and then whatever this pitch is for Paul, the velocity difference is going to fall mostly right there. If we go back and look at shoulder speeds, we can see Luke's shoulder speeds, I think, hit a 1.3. Look at Paul's shoulder speeds going forward. Okay, they hit a 0.67, which shoulder speeds are pretty much connected to the trunk. Let's see the elbow speeds at this point. You'll get an idea of really, now we're getting more into the arm speeds, 2.3. See Luke's elbow speeds, 2.79, and then wrist speeds going forward, 3.48, 3.8. So almost caught up with the wrist speeds, but pretty significant in the trunk dynamics. You could see Luke, just recap, looks like he definitely had better mobility in his hips, was able to get more momentum going earlier, was able to peak forces later, a lot higher, a lot lower in his center of mass in the front foot. He stayed in a more closed shoulder or more closed front foot position and hip and shoulder orientation. He then didn't stabilize as well as Paul, but transferred a lot more energy forward into that trunk, considerably more energy into that trunk through the arm, which really made up the difference. So Paul just needs to work on the lower half movements, getting more linear energy through them, building more of the back leg drive power, and and trying to keep the front leg dry or stability that he has, and getting that trunk to receive that energy. That's going to be the key for him to really make some improvements.